Hello friends, today we're going to talk about data-driven development and why it has gained so much importance in these times. So the first question that comes to our mind is why do we care so much about data? Or why should we actually care so much about data? So data is everywhere and new data-driven business models are emerging even for traditional industries. Earlier, data and its related business models were seen as more suitable for industries such as finance or in recent years IT because they generate a huge amount of data. Data has now become the new oil and is actually becoming a marketplace. People are trading data and they are getting they are actually using as it as a commodity, and more of our actions and interactions are actually becoming mediated by data. So data has actually changed how we make choices and what choices we make. A typical example would be the way we rent books or movies now has completely transformed as compared to how we would do in earlier times. So in earlier times, when we wanted to rent a book or a movie, we would typically go to a library, and then in the library we would look out for the section that is of interest to us, and that section we would randomly pick up certain books or movies and look at the preface or the summary of the book or the movie, and based on our experience about reading this summary or preface, we would decide whether we want to rent this book or movie. But now the way we select movies is totally changed. So what we do is typically first we go out on the internet and try to find out reviews of these movies, that is say how something like Rotten Tomatoes or say IMDb has rated this movie, and then we would actually look at recommendations from people who have similar liking from us as us. So the whole process of making choice and the type of choice that we made has actually transformed. So nowadays we are doing more objective form of decision making. So data-driven development has led to automation of tasks that were earlier thought of quintessential to human skill. One such task is wine tasting. So in wine tasting, traditionally over the years, for rating a particular wine, experts would be called and they would actually take the wine in the glass and they would swivel it and see the clarity of the wine. Then they would smell it to understand the nature of the wine, and then they would taste it and then give a rating to the wine. But even this task has now been automated by data driven models. So a company called Analytics is has developed a correlation between the chemical composition or the molecular model or the molecular topography of the wines and the quality of wine. So they've developed a correlation that if a wine has a certain molecular composition, then it is bound to have a typical rating. So they found this correlation by analyzing the data between the chemical model and the ratings that they were given over the years by experts, and have been able to successfully uh, be, rate the wines based on this with a high precision. Another such change that has happened, so when Hurricane Katrina was about to hit the coast of United States, a large retailer actually did a study on what products it should emphasize and stock up on so that they can gain maximum profits. So they decided to actually meet together in a room and kind of brainstorm on what particular products would make the most of the sense to stock upon in such situations. So among the people who were actually part of the meeting, some of them suggested that flashlights could be one such product which should be stocked, because usually there is a power failure in such circumstances when there are storms and hurricanes, and so that would actually be quite beneficial. Some others thought maybe batteries is a good option, because when when there is no power, people might depend on battery power to actually light up their homes. Some other person suggested that probably water is the right choice to right the drinking water is the right thing to actually stock upon, because in cases of such storms it is difficult to find drinking water. And someone suggested that due to the storm and accompanied rain, there would be a lot of moisture and there would be a lot of wet places, so people might be stacking upon sandbags to kind of make the places dry. And someone actually suggested that canned foods could be a good option, because uh, in such situations there is usually a shortage of food supply, so people would like to kind of stock up on canned foods. After brainstorming, they also ran an analytics on their past sales in such situations, that is, in a situation of an hurricane, and they found quite an unusual product that was sold most during these times. And that product was Budweiser beer. So, with this analysis, we see that even with the best minds using their intuitions and hunches, uh, might get to a conclusion which might not agree with what we could have got from data analytics. So data is actually empowered decisions and helps us to go an extra mile beyond our intuitions. So these days, almost everything can be tested, measured, and improved. And this is truly bringing about a fundamental cultural transformation in how we make decisions. So in electronics and related industries, these days, almost every equipment is now fitted with a sensor, and the users are and the manufacturers are continuously kind of recording this information about how these products are being used, and what causes these and do a predictive analysis on when these products will um, are going to get are going to fail, and when these products need a repair, so they can do all this analysis based on the data that they collect about these products. So now the dynamics has actually shifted from hunches, guesses, and intuitions on data-driven decision-making approach. So earlier it was people and hierarchy. So um, it was people who were taking all the decisions, and they were taking it based on their vast experience that they had gathered in the field. And there were hierarchies made that certain type of decisions would be made only by people at a certain position. So that was the trend earlier, but now it has totally been replaced by data and analytics. That is, people are now dependent on data and analytics combined with human understanding of the subjects to actually get to decision making. Data analytics and tools also help us in identifying key decisions regarding the products that we make. So, according to a study shared by Jim Johnson, the chairman of the Standish Group at the Third International Conference of Extreme Programming, it was found that almost 65% of product features might never be used or rarely used for a product. So that brings us to certain questions that whenever we are actually doing creating a new feature, will this feature actually deliver value to the customers? If it does, then by how much? And which of the product variations will have the most impact on customers? What changes to our products have the largest measurable impact? So people are now looking for all answers to all these questions, because it is the data that actually drives the product. So in a data-driven product development, there are 5 stages. The first one is analysis and research. The second one is problem and ideation. The third one is feature definition. Fourth is design, and fifth is implementation and deployment. So analysis and research, typically what we do is we try to gain information about what is the customer looking for, or what are the pain points that the customer is having. Based on customers pain point and the problem that customer is facing with the product, people come up with solutions to the problem, and then they create a problem, and they document the problem and document the solution. Then they go on in explaining about what actually needs to be done with the problem. Then they design a particular solution that solves the problem, and then this design is implemented and deployed. And once this design is implemented and deployed, it is pretty important to see if it is actually giving us solving the actual problem, that is it is actually giving the much required results. So analysis and research which requires us to analyze what are the users doing or what are they failing to do. So for this we use quantitative data to identify trends. The second problem is why. The second point of focus is why are they doing this. So we use qualitative interviews to determine what is driving these trends, or what is why the user is doing what he is doing. Now the first step in this process is to identify the key metrics or KPIs for the product and prioritize them. That is, uh, so it is basically different for different products. For a IT product, it would be different. For example, for an IT product, it could be something like what is the sign up rate? That is how many users are signing up to your service. Or what is the conversion rate? That is people who are downloading your software, are they actually going? How much many of them are actually buying the license or subscription? And how many, then third could be the daily, weekly, monthly active user. That is how many unique users are present on the platform every day, every week, or every month. And then one of the KPIs could be what is the retention rate, that is the number of users that return back to the platform every 1, 7, or 30 days. So it is important to quantify these KPIs and create regular reports to track how we are doing against these KPIs. For a traditional industry like say manufacturing, the KPIs on similar grounds could be like, say for example, for a vehicle it could be important that how many vehicles are being sold every year, and what is the fuel economy that we are getting. Then there could be certain other KPIs like what is the how better can we actually use the products so that we get a longer life. So these could be some questions that could come from the traditional industry. So the next step in this process is to study the KPI and identify what affects the KPI in positive or negative way, and by how much. That is what drives these KPIs. Is there any particular user behavior or any user classification which affects this KPIs? So for this particular process, we use machine learning models and data analytics to identify the correlation and effect between KPIs and the data that we collected, and try to know more about the problem at hand. Once we have derived the KPIs, we set an expected quantifiable outcome. That is what we are going to achieve when this particular problem is solved. For example, one of the expectable quantifiable outcome could be that the new user sign up rate should increase by 10%. Then we actually interview the users to gain insights about why they are doing what they are doing. and we try to understand if we are in alignment with their expectations. For example, we could find out that the user is actually facing a friction in sign up process, and that's why our monthly user signups are less despite larger number of downloads. And we might figure out that he or she thinks that the sign up process requires user to enter a lot of data initially, and hence installs are decent but sign up rate is still low. The next phase in this cycle is problem and ideation. So in this, what we do is we figure out a problem statement that is a summary of the issue that users are facing. So an example could be friction in sign up process. Then we come up with the solution or the idea, that is the proposed features that solves the problem. For example, in this case of friction in sign up process, it could be allowing Google, Facebook based login to prefetch user info from these sites so that user has to enter minimal information. Once we are done with problem and ideation, the next step is detailed description. So we write a user story to actually define what is the problem at hand in detail. That is, the user is facing sign up friction, and then we are also detail what write in detail what is the solution to it. For example, in our case, it would be enabling Facebook and Google sign up support by including the respective SDKs, and then performing the required integration with these. So basically what we are doing is we are prefetching the user information from these sites so that user has to input as less information as possible. And if this is a new feature or a new thing that we have added into the product, then we include event tracing to track how the feature performs. Now, event tracing is something which is particular to the IT products, but in case of manufacturing, it could be installing sensors to collect this data and sending it to somewhere in cloud. The next process in this cycle is design. Once we have identified how we are actually going to solve users problem, we create a prototype and place it in front of users. Then we do A/B testing to see uh, if the new design that we have come up with do the users prefer the previous login flow or the current login flow. And if we figure out that yes, the user is definitely happy now with the current login flow, then we would actually create designs and we would export the design files for the developers. Once the designs are ready, the implementation phase starts. The developers work with the design to complete a prioritized subset of the features. So in our case, it was just one feature that we were working at. That was the login sign up process. But it could be that while looking for customers' pain points, we might figure out more than one things to be uh, corrected. So in that case, sub, we might have a list of features to be implemented, and in this, and so we would actually prioritize the subset of the features, and we would release it initially for a smaller audience. That is, we do the beta testing or the pilot testing. Once we are satisfied that the new users in the beta testing or pilot testing are happy with the new design, then we kind of uh, decide to release it for a larger audience. Once the implementation and deployment is complete, we again go back to analysis and research. And here we actually kind of try to figure out that are we actually achieving the quantitative benefit that we had actually set up, the benchmark that we had set up for this. That is, suppose if we had actually decided that in analysis and research that we would actually get 20% benefit or the 20% increase in sign up rate, are we actually achieving this set targets? And this is actually an iterative process which we continue to run and try to create or improve product features using this process. Now, in one of the steps, I told that we kind of use ML models or data analytics to identify the correlation between the KPIs and the data at hand. So that process actually, I would like to discuss a bit of that process in detail. So the first step in that process is business understanding. In business understanding, we try to set up the context, that is what the problem domain is, and we try to gather as much understanding of the problem at hand as possible. In the second phase, that is data mining, we try to get the data that is related to the problem at hand. In the third phase, we try to clean the data, that is to make the data uniform and without any empty values. In the phase, we try to do data exploration, that is we try to gain an understanding or a feel of the data at hand. In the fifth stage, we do feature engineering, that we create features that are more suitable for the model that we are building. In the sixth phase, we do some kind of a predictive modeling in which we kind of predict what are the factors that actually affect the KPIs and by how much. In the seventh phase, we do some kind of a data visualization to back up our findings by the data model using graphs and such tools. So going a bit in detail, so business understanding is the process wherein we understand the business or activity whose metrics we are trying to analyze. We try to get all the necessary context. This helps us in setting up a clear objective about what we want to do with the metrics, that is a concrete question to answer, and gives us the necessary direction and purpose. Once we have the context of the problem at hand, we try to get into data mining. We try to identify sources from which we can actually get this data. So if you're a new startup, probably we do not generate this data ourselves and we may be dependent on some third party to supply this data so that we can analyze and derive conclusions out of it. If we are an established firm, then most probably we will have our own data generating repositories, and from there we can actually fetch that data. So we try to mix and merge data from as many data sources as possible. So, and we'll try to look as far as possible for data. Once we have the data, it is actually time to look at all the data at hand and ensure the data is homogeneous and clean. Sometimes it happens that the data that we have collected is either has got some empty rows and columns which need to be substituted by suitable values, or we may have rows which are almost completely blank, which might require us to delete them. So so the data that we have got in raw form may have missing or inaccurate values, and it may require appropriate cleaning so that the output data is void of missing and inaccurate values. So once we are done with data cleaning, we do data exploration. In data exploration, we try to get a feel of data, that is first we try to analyze if the data that we have at hand is first of all we try to find out if the data at hand is appropriate or do we need to collect some more data. Then we also do some data analysis which help us to understand and interpret and derive conclusion based on the requirements. The next phase in this is feature engineering. So feature engineering basically means to build new features using old features. So let's take an example. For example, we are more interested in, say, we are interested in buying property in a certain area, and the data that we have at hand has features such as the total square root or the total size of the different plots in that area or the houses in that area, and what is the total price of that house. So deriving a feature such as say price per square feet might be more interesting to us, because that is one feature that would help us to make the model more efficient. So we what we do here is we try to transform raw data into features that better represent the underlying problem statement to the predictive models. The next task in this process is predictive modeling. So in predictive modeling, what we do is we run machine learning algorithms to go a step further into getting insights and predicting the future trends. So there are certain learning algorithms. So based on our need, we choose the particular learning algorithm, and we try to develop a model based on that learning algorithm, and that learning algorithm could give us either a classification of users, or it could give us certain particular figure out certain particular features, uh, and help us in getting insights and predicting future trends. By analyzing past data, models find features that have impacted past trends and use them to build predictions. So it is more than just gaining knowledge, and this final step can lead to building entirely new products and processes. The next step in this process is data visualization. So whatever analysis that we have done in the previous stage and whatever features or the classifications that we have got, we now need to represent it to people so that they can understand it in a more clear way. So we need to present it in a more in a form which is understandable better by other people. So we kind of try to support our findings by drawing graphs and other visualizations. The goal is basically to communicate information clearly and efficiently. Through data visualization, we highlight the metrics that greatly affect the data that we have at hand. Now, there are always challenges in things that we do. So data-driven development comes up with its own challenges. The first thing is identifying the right data to collect. So data collection can be expensive because you need to tag the data, run A/B tests, find out click rates, and do analytics. So it is very important that we should have the right data at hand, or otherwise the efforts that we are putting in all the analysis will go in vain. And it is important that the data should be as complete as possible, so that people who are actually analyzing data, their focus goes or their efforts goes in mostly in analyzing the data and not in making the data complete. So the challenge here is to decide what data to collect and then analyze. The second challenge in data driven development is that we may be actually following a market and not leading it. So in data driven development, specifically what we do is we kind of take an account of the data that has been collected in the past, and we try to derive conclusions based on it. Now, some people might argue on this that since this is a whatever we are deriving is based on past and not based on future, so the insights that we are deriving may not be forward looking and maybe actually following a market and not leading it. And they might view this product development as an engineering extension of market requests. The third challenge is of data-driven development is it requires infrastructure and organizational changes. Since we will be collecting a lot of data, we actually need the right infrastructure in place. We need to have big data repositories where we can actually uh, store humongous amounts of data, and we also need to have organization changes, that is we need to have certain dedicated teams which specifically take care of storing the data, analyzing the data, creating, handling issues while collecting this data. And so we need specific teams that need to take care of such things. Also, companies need to have the right mindset. So people so far have been dependent on hunches and intuition based, and have been making intuition based decisions. So data driven development actually comes up with a total new philosophy that decisions should be driven by the data that has been collected at hand and not by intuition or hunches. So that uh, mindset needs to be developed by each and every person involved in decision making. The next thing that's important in data driven development, or the challenge, is the data that is collected should be actionable. While we agree that we need to have as much data as possible at hand, and we need to analyze that data to find the right features, but when we actually kind of analyze this data, we must be able to get some actionable insights out of it. It should not be that the data is siloed, incomplete, and resulting in insights that are not actionable. Another challenge in data driven development is the data needs to be reliable. That is, firstly, the collection methods used. For first party data, we are actually, or the data that has been generated by us, we are pretty much sure about the quality standards being followed and the collection methodologies that have been incorporated for collecting the data. We are quite sure about it. But when businesses engage in a second and third party arrangements, collection methods are not always transparent. So we need to be quite careful about, and we need to have some due diligence before actually getting data from third party. Also, it is important that the purpose of collection behind the collected data should be same as the subject of exploration. That is, data should have been collected for the same reason for which it is being analyzed. It should not be the case that the data was being collected by for, for some other reason, but is being used for analysis for some secondary reason. And the seventh thing is statistics about statistics. So that's a bit of humor on it. The challenge in data driven development talks about the fact that 56.7% of all statistics have added an extra decimal to seem more trustworthy. 10 to 80% of all statistics are more or less imprecise. 20% or about one fourth of all statistics contain miscalculations, and 30% of all statistics are inconsistent. So that's about our journey into data driven development. Thank you for joining, and have a nice day.